Hello, future engineers. Welcome to my YouTube channel. If you're still new to my channel and you like what I'm doing, please don't forget to subscribe and share my videos to your friends and to your friends' friends. That's the only way you can help me promote my channel and to keep me going, refreshed, and inspired. And I'm very willing to share my knowledge, especially topics in civil engineering for your benefit. The steel cantilever beam consists of two cylindrical segments with the diameter shown. Determine the maximum displacement due to the 1,800 Newton concentrated load. Use modulus elasticity of steel of 200 gigapascals. So here is the given figure. This is our origin. So there is C sub 1 and C sub 2. And for portion BC, there is also C sub 3 and C sub 4. So let's compute for the moment of inertia. Call that x first. So IAB is equal to pi over 4 radius 25 mm to the fourth. So it is 306,796 mm to the fourth. The moment of inertia of portion BC is pi over 4, 37.5 radius to the fourth. So it is 1553156 mm to the fourth. So it is 5.0625 of IAB. So we will call IAB equals I, and this 5.0625 is of IAB is moment of inertia of BC divided by moment of inertia of AB. So 1553156 divided by 36796 is 5.0625 of IAB, or 5.0625I. So there are two differential equations for segment AB and for segment BC. Take note that for AB, it is from 0 to 0.915 meter. For BC, to be applicable, it is 0.915 to 0.915 plus 1.525 is 2.44 meters. The applicability of the equation for BC. Now, take note that B for these two segments, what is common is theta B or y prime when x is 0.915 and delta B. The values would be common for AB and for BC. So let's now establish the differential equation for AB. AB y double prime AB is equal to negative 1870x. So y double y prime AB is negative 95x squared plus c sub 1. Integrate again, y AB is equal to negative 95 over 3x cubed plus c sub 1x plus c sub 2. So we expect slope and displacement at A. That's why there are c sub 1 and c sub 2. Then for BC, so that's the section. So E times 5.0625 I BC, y double prime BC is negative 1870x. Dividing everything by 5.0625. So EI y double prime BC is equal to negative 369.38x. Integrating, EI y prime BC equals negative 184.69x squared plus c sub 3. Integrate again, EI. So that distance is 2.44. So EI y BC equals negative 61.56x cubed after we divide by 3 plus c sub 3x plus c sub 4. So we can use this equation and this equation to solve for c sub 3 and c sub 4. First, for c sub 3, take note that when x is 2.44, we can only apply it here. The slope at c is 0, so y prime BC is 0 here. So 0 equals negative 184.69 times 2.44 square plus C sub 3. So therefore, C sub 3 is positive 1099.57 Newton meter square. This first slope. Then into this equation here, when x is 2.44, yc is 0. So 0 equals negative 61.56, 2.44 cube plus c sub 3, which is 1099.57 times 2.44 plus c sub 4. So we can now solve c sub 4. C sub 4 is equal to negative 1788.68 Newton meter cube. Then for the common value, theta y prime AB is also y prime BC when x is 0.915. So y prime AB, which is this, when x is 0.915, so negative 935 times 0.915 square plus c sub 1 equals EI y prime BC negative 184.69.915 square plus c sub 3, which is 1099.57. That's it. So we can now solve C sub 1. C sub 1 is equal to 1727.75 Newton meter square. Also, when x is 0.915, y delta B or y AB is equal to YBC. So this is equated to this value here. So negative 935 over 3 times 0.915 cube plus C sub 1, which is unknown. C sub 1 1727.75 times 0.915 plus C sub 2 equals negative 61.56 times 0.915 cube plus C sub 3 1099.57 times x, which is 0.915 plus C sub 4, which is negative 178.68. So from there we can solve C sub 2. C sub 2 is negative 2171.87 Newton meter cube. Therefore, when we compute for the displacement at A, that is x is 0, so EI delta max, maximum displacement at A, or YAB max, is equal to, because x is 0, so 0, this is 0, so what remains is C sub 2. Therefore, EI delta max, where E is 200,000 Newton per mm square or megapascals, times I, which is 306796 mm to the fourth, delta max equals negative 2171.87. That's Newton meter cube, so we multiply 1000 cube to convert it to Newton mm cube. The left side is Newton mm square times delta max in mm, so Newton mm cube, and that's Newton mm cube. So delta max is in mm. Delta max is negative 35.396 mm. The negative sign indicates that the displacement is downward. So that's it for this problem.